welcome to NSOMASA NMIMS podcast, where we bring you exciting conversations with the thought leaders from various fields. I am K.S. Madhav Rao, Professor of Statistics from the Department of Statistics, NSOMASA. Let us welcome our today's guest, Dr. B.L.S. Prakasa Rao, who delivered the inaugural address of ICS 2023. Professor B.L.S. is an emeritus professor of the Indian Statistical Institute and an INSA senior scientist at C.R. Rao Advanced Institute of Mathematics, Statistics and Computer Science, Hyderabad, who has been interviewed by Rishikesh Thakur and Shraddha Kodavade.
Hello and welcome to the very first of its kind podcast, where we, the students of ICS conference organized by NSOMASA NMIMS, have cumulatively gathered to seek and store the overflowing wisdom of our eminent and world-renowned guest speakers. My name is Shraddha Kodavade from M.Sc Applied Statistics and Analytics.
And I am Rishikesh Thakur, M.Sc Statistics and Data Science.
We are the hosts for this podcast episode. We have with us today Honorable Professor Dr. B.L.S. Prakasa Rao.
Professor Dr. B.L.S. Prakasa Rao is an Indian statistician. He completed his BA Honours degree from Andhra University in 1960 with a record-breaking performance and moved to the Indian Statistical Institute, Kolkata, where he completed his M.Sc degree in statistics in 1962. He graduated with a Ph.D. in statistics from the Michigan State University, USA, in 1966 under the supervision of Professor Herman Rubin. Professor Prakasa Rao's major research interests are in the area of stochastic processes, stochastic inequalities, characterization of distributions, and limit theorems in probability, and in the areas of parametric and nonparametric inference in statistics. Professor Prakasa Rao has published more than 300 articles in national and international journals, and has authored and edited 18 books in the areas of statistics and probability.
He has visited several universities all over the world during more than 30 academic visits abroad. Professor Prakasa Rao was the editor-in-chief of Sankhya Series A and Sankhya Series B during the years 2012-2015 and was a member of editorial boards of several national and international journals over the years. He has also held visiting professorships at University of California, Berkeley, University of Illinois, University of Wisconsin, Purdue University, University of California, Davis, and University of Iowa in USA.
He was Jawaharlal Nehru Chair Professor 2006 till 2008 and Dr. Homi Bhabha Chair Professor in 2008 till 2012 at the University of Hyderabad and the Ramanujan Chair Professor 2012 till 2017 at the C.R. Rao Advanced Institute of Mathematics, Statistics and Computer Science, Hyderabad. Prakasa Rao was awarded the S.S. Bhatnagar Prize for Mathematical Sciences in 1982, Outstanding Alumni Award by Michigan State University in 1996, Distinguished Service Award by Mathematical Association of India 1999, Best Paper Award by Indian Society of Agricultural Statistics in 2000, Lifetime Achievement Award by Indian Society of Reliability and Statistics in 2015.
He was President, Statistics Session, 83rd Session, Indian Science Congress. Prakasa Rao sir received the National Award in memory of Professor P.V. Sukhatme for outstanding and meritorious research work in statistics in 2008. He was elected Fellow of Institute of Mathematical Statistics USA in 1983, Indian Academy of Sciences Bangalore 1992, National Academy of Sciences India, Allahabad 1993, and Andhra Pradesh Academy of Sciences 2012. He is presently an emeritus professor of Indian Statistical Institute and an INSA senior scientist at C.R. Rao Advanced Institute of Mathematics, Statistics and Computer Science, Hyderabad.
We are extremely humbled and honored by your presence here. Thank you for joining us today. Hope you're having a great time here.
We have so much to ask and we have very little time in hand, but nevertheless, we'll get started. So the first question is, everyone has a eureka moment in their life. So something on the similar lines of how Newton had a moment where the apple falling legend that Isaac Newton had. When did this eureka moment, when this awe-infusing moment occur in your life, when you realize that numbers or maybe something that dealt with data and statistics was something that draws you or something that belongs to your core? And along this journey, did you face any challenges throughout your learning trajectory?
Well, thank you very much for your introduction. It's very kind of you. It's actually, in my case, statistics just happened. See, when I graduated from school in the earlier days, I was too young to go for an engineering program. It used to be in those days, you have to be minimum 16 years to get to engineering college. I was only 14 by the time I finished my high school and intermediate. So they said, you are too young. And then I opted for mathematics. And then I wanted to go to Indian Administrative Service. So then I thought if I study statistics along with mathematics, then that should be hopeful to get a test good marks in the ICS exam. But then I found out you cannot have mathematics, applied mathematics, pure mathematics, and statistics as the three subjects. So then I went to the mathematics honors at Andhra University. And then after my mathematics, I went to Indian Statistical Institute. But even then, I was too young for an administrative service to appear for the exam. I was only, I think, 19 when I finished MA and M.Sc. So I was too young for administrative service. So then I joined a Ph.D. program. So that's how I came. So statistics happened to me like that. So I didn't start with things, but then my interest was in research programs. So actually in M.Sc program, we had what are called specialization. You can do one of the specializations. And maybe I can tell you right now, I was the first batch of M.Sc students of Indian Statistical Institute who became the director. I will talk to you about it later. So I was in the first batch. So in M.Sc, there are three specializations in those days. One is quality control and operations research. The other is economics and planning. And the third is advanced probability and research. And I joined the third group. That's how I ended up with specialization in statistics. So I can't say there is a eureka moment, but the life has taken me in that direction. And then after my master's, of course, I went abroad, and I'll talk to you a little bit later about that. Thank you.
Thank you, sir. So the next question is, you have had the opportunity to work with and learn from several renowned statisticians, and one of those encounters was with Dr. C.R. Rao. So would you like to enlighten us with how he impacted your learning and how that encounter changed your life?
Oh, that's a very, very interesting question. Because you see, ISI, I was fortunate to have the world's greatest statisticians and probabilists as my teachers, starting with Professor Rao. Professor C.R. Rao, then Professor Raghuraj Bahadur. He's a very well-known probabilist. And then there is Professor S.K. Mitra, who works in matrix theory and large sample theory and so on. Then Professor John, Professor Murthy, and Professor S.R.S. Vardhan, who got A.B.L. laureate position. So I think Professor D. Basu. So these are all outstanding mathematicians, statisticians, probabilists. I don't think any students want anything beyond that. So I was fortunate, and it so happened I was also in the first batch of the students. So we enjoyed working. But then our program was very strict. So Professor C.R. Rao formulated the program for us. And I can tell you, it's such a tight program that we have to learn both theoretical statistics and applied statistics. For example, we had exams every Monday, and we had courses from, all the time. And not only that, we had to go to a village to do surveys and collect data and analyze them, and which is not done nowadays. So sample surveys is part of our education. And so you can imagine I learned theoretical probability and advanced limit theorems plus sample surveys as a part of my curriculum. And of course, design of experiments and all that. So it's a very intensive program. And we're all grateful to the type of program. And at that time, there was also a bachelor's in statistics program which started by ISI. It was much more intensive. And these are the first programs approved as a part of programs by the Indian Statistical Institute, which was declared as the Institute of National Importance by the Government of India by an Act of Parliament in 1959. So that was probably the first educational institute which is declared by the government. And Professor Rao was the head of that. And Mahalanobis, who was the founder of the institute, who founded that institute in 1931. So that's the story behind that program. Thank you.
Thank you, sir.
So we have heard the quote, data science is just rebranding of statistics. And due to the volume of data, the term big data was born. Concepts like sampling, sufficiency, limit theorems show us that from the past, we have been relying on these techniques to deal with big data. So coming to the point, statistics was and has always been present irrespective of how we coin it. Let's visualize a Venn diagram that combines data science, ML, statistics, AI, big data. What do you think are some of the misconceptions that take place due to this interdependence in concepts that need to be done away with right away?
I think, as I said in my lecture yesterday, so my personal impression is data science is very important, but that's not the end of all. In fact, probably all of you know that data mining used to be a subject much earlier before data science has come up. So, you see, to put you in the proper perspective, so when I learned statistics, there were no computers. We never had desktop computers. There were not even calculators. We started with what are called mechanical calculators. So if you want to do regression analysis, you really have to do using mechanical calculators and do that. But then those type of techniques are not useful when the data size is very large. So the work, big data and analysis has come up because of the advent of computers now with high power computers. Even computers, probably some of you might not know that ISI was the first computer was in the whole country. It was in the ISI. But then in those days, computers are so big in volume and size, but not that powerful. But now things have changed. You can do most of the calculations on your pocket calculator. So the data science has come up because there is so much computation that can be done with the data that is available. And as they say, this data speaks for itself. So if you want to analyze something, there are what are called parametric and nonparametric models. So parametric model is you have some model behind that, and then you just find out some parameters which are unknown. Whereas non-parametric models means that's where the large amount of data is needed to really understand the variables behind which lead to this response. So in the data science is good in that sense. We use the data only to understand what are the variables which are behind, like covariates or variables which lead to the corresponding response. The selection of variables is very important. As I said yesterday, if p equal to 50, there are 2 to the power p minus 1 sets of variables which are impossible to analyze. So only computers you can use. So the languages have to be learned, as I just said a few minutes back to some people. So languages like Python, R, all these things are needed to learn data science. So data science is a combination of mathematics, statistics, and computer science. In fact, with this, Professor C.R. Rao started the institute in Hyderabad with this vision 20 years back. So you can imagine, he knew that all this computer programming, all these techniques, languages are needed to analyze large amounts of data. That's why big data is playing its role. But as I again said, big data is not the end of all. You need small data analysis are also important, equally important. But big data has its own challenges, its own usefulness in this day-to-day life. Thank you.
Thank you, sir.
Thank you, sir. The next question is, one of the ways to characterize a data set as big data was highlighted in your talks recently, that is yesterday, where we said that big data was characterized by its massive sample size and high dimensionality. Something revolving on the same lines is that because of the volume of data, we also have concerns of privacy. And when United Nations, let's say institutions like United Nations, they some of the jargons that I have come in contact with while I was reading about big data over there was differential privacy, secure enclaves, or something on the lines of synthetic data. So the goal over there, the things that they were talking about over here was striking a balance when they want to make the data set public, but they also want to maintain the privacy of data. So while we're striking this balance between how to arrange the big data but also maintain its privacy, what are certain techniques that go around with the anonymization of the data and also the privacy overall about how do we deal with big data and the privacy aspect of it?
Well, again, as I said yesterday, I didn't pursue it much. Ethics and confidentiality are lost in big data. So that's why sometimes they use some masking for the data. Masking can be done several ways, either by coding or by employing some, you add on to your data some random noise. So which you can again extract using, there are techniques of extracting information from the data by using some deconvolution aspects, messages. So that can be done by masking. But then when there's a big data, there is also the fact that your individual things are not are really masked. People, when you give some, of course, if we give our Aadhaar, wherever I go, they want an Aadhaar card information, which is not right really, because Government of India has given 16 cards like driver's license and so on, but everybody wants Aadhaar. Yesterday, somebody was talking about banking. When you go to a bank, they want an Aadhaar card. So this is a big data, and all the information is confounded there. So this one way of aspecting is by masking, but then there is a danger in the long run. For instance, if there is some problem, it's what they call darknet or something like that, the people misuse the data. Then there is a danger with that. So that aspect is always there. So how to eliminate that is not clear. So using these ideas of masking and removing some important information which is anonymous, so this can be done, but one has to be careful. Thank you.
Thank you, sir.
Thank you, sir. So, as a language model, ChatGPT has the ability to process and analyze vast amounts of text data. With the rise of big data, what role do you see language models like ChatGPT playing in the analysis and interpretation of large-scale textual data? And what potential do you see for statistical methods to be applied to this field?
Well, that's a very interesting question, because I don't know much about ChatGPT, whatever I know from the newspapers which I read. But I think, as everybody says, computer language, as all of you know, garbage in, garbage out. So ChatGPT does what is already there. ChatGPT doesn't think. So it extracts information for what is already in present there. So, of course, I understood ChatGPT is being used by a lot of students for their accounting and performance and in exams and so on. But I really don't know how it is going. But then, people will find out, the professors will find out how to come out of this ChatGPT analysis. So, but how it is going to helpful for data science, I have no idea. I cannot answer the question that much because there is no data. So far, there is no data on how it's being used or misused or abused.
Thank you, sir.
On the same lines, with the rise of artificial intelligence and big data, the younger generation is being exposed to all these concepts at unprecedented rate. Do you think it's a positive development, and what impact do you think this exposure to AI and big data will have on the younger youth of our country, or maybe the overall younger youth?
Well, let me say a few things. Maybe, see, there is a subject called multivariate analysis in statistics. So there, you study the correlations between several variables. And we learned, just remember I learned during 60s, 1960 to 62. At that time, when I learned, we have what is called supervised classification and unsupervised classification. Supervised classification includes, that means if you want to classify an observation, there is already some information you already have. And then you classify your observation either into this class or that class. And unsupervised classification means you train the data, and then whatever data you have from that, you fix up what are the things. So artificial intelligence, all these things are new concepts, but they are old wine in a new bottle. So it is. So these are already known. Some ideas are there. So this artificial intelligence is actually learning from data. So it is past data is there, using that. How, what are the, you extract the information of that and then use it into the next step. It's like adoption from earlier things. So artificial intelligence is good. And again, it has come up as a new subject because the computing facilities are more now. So earlier there was nothing, but the ideas are the same. So I think artificial intelligence seems to be helpful for in so many areas, but whether it is how it is going to work out in future, only the future will tell. Thank you.
Thank you, sir. So the Neil Kaval School of Mathematics, Applied Statistics and Analytics, short NSOMASA, offers two master's programs, namely M.Sc Statistics and Data Science and M.Sc Applied Statistics and Analytics. Three other undergraduate programs offered are in the streams of Applied Statistics and Analytics, Data Science and Artificial Intelligence. Did you have the opportunity to look into the program structure and reflect on their suitability in terms of international benchmarking, imparting graduate abilities, industry preparedness, and placement?
Well, I have, as I said a few minutes back, so I have taught at several universities here and abroad. Starting from, I taught courses at undergraduate students, freshmen, they call them there, freshman, sophomore, junior, senior, and masters, and also at a Ph.D. level. What I found out at that time, for instance, let me go back to Indian Statistical Institute. I did my work in advanced probability and in my master's program, but then I had to learn sample surveys, statistics, design of experiments, so all these things. So in other words, whether I'm an applied statistician or a theoretical statistician, our program is balanced. So that is what is important. That is needed. And I see that from the list of courses which you have, it is like that in your program. But when I went abroad as a student at Michigan State University, I found out the statistics students who are graduating from there never had any sample surveys. They didn't even hear about sample surveys or design of experiments. So that is not balanced. So I think that's what one has to be careful. So it is not enough if you learn advanced mathematics, but then as a mathematics master's, I have a master's in mathematics also. So I do feel a good mathematics is necessary to learn good statistics. So they go in hand. So if you want to do some research, for instance, you need to go have good mathematics. But if you want to do applied, you might not need that very good mathematics background, but you certainly need a good understanding of that. So your courses here, I see that, I'm looking at your B.Sc data science. You have number theory, of course, is important now for coding and all that. Then you have sampling courses also. So, of course, you need to have new languages are important, especially if you want to do data science. Languages like Python or training in those things is also important. So as I said, as Professor Rao said, for the institute, you need a good background in mathematics, statistics, and computer science. You can't avoid computer science now. Any statistician, it's a basic things in computer science are very important. And even whether you want to be a theoretical one or you want to go and actually apply it in day-to-day activities, you have to have a good background in these subjects. Thank you.
Thank you, sir.
And sir, winding up the session, the last question is, did you ever know about any of the co-faculty in Department of Statistics in NSOMASA? And if so, how well you know them, their research interests and publications? If not, do you have any opinion on the broad profile background of co-faculty and the research areas of interest?
That's a difficult question to answer because I am not familiar with math. Of course, I know Professor Rao, Professor Madhav Rao, I knew him. So I was a visiting professor at the University of Pune for 2 months way back in 1977. And I understand he was there a little later than that. The Pune University is, Professor Adke was the chairman at that time. He was interested in inference for stochastic processes. In fact, that is my research field. I work in that area. All my books are on inference for stochastic processes. So I see that some of the faculty here are interested in such areas. Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much for your valuable time and patience. With this, we come to the end of this podcast session. Thank you for tuning in. We also want to express our gratitude to the platform that ICS and NMIMS have given us. Thank you so much.
Thank you. Thanks for inviting me. Thank you.